Well, we previously looked at the graphs of the sine and cosine functions with a heavy emphasis on sine. Today on IXL, you'll be able to practice some more with the graph of the sine function and graph of the cosine function. But let's take a look at the other four functions we've not looked at yet. So again, if I was going to graph the old-fashioned way, if I had no clue what the graph would look like, I would make an input-output table. And of course, as I go around the unit circle, the input would be the angle in radians, and the output for tangent would be opposite over adjacent, also known as sine of the angle divided by cosine of the angle. And we start getting some interesting situations here. You'll notice that pi over 2 are undefined, because sine of theta would be 1, cosine of theta would be 0, and 1 divided by 0 is undefined. And so as we race around the circle, we start to find ourselves every pi units that we have a situation where undefined, right? Between pi over 2 and 3 pi over 2 is pi units. So when we graph the function, remember, every time we're undefined, we need a vertical asymptote, right? And so we'll get infinitely close to those vertical asymptotes as we head up to positive infinity and down to negative infinity, but we'll never actually touch them or cross them. You can cross horizontal asymptotes, but you cannot cross vertical asymptotes, because with a vertical asymptote, that's a situation where you're undefined. Horizontal asymptotes, of course, refer to limits, and you can approach the limit and even cross over the limit. So you'll notice every pi units, we've got a vertical asymptote. The period happens to be pi. Every pi units, we've got a complete cycle because it repeats itself. The domain, you can plug in anything you want for x, as long as it is not pi over 2 or a multiple of pi units from pi over 2. The range, negative infinity to positive infinity, because it can go down as low as you want or as high as you want. And of course, the vertical asymptotes occur every time x equals pi over 2 with an additional pi units. Cotangent, very similar. You'll notice, however, that the asymptotes, instead of being at pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2, the asymptotes are actually at pi, 2 pi, 3 pi, 4 pi, 5 pi. I should note there's an asymptote that's not clearly labeled in that diagram. When x equals 0, of course, the y-axis is also a vertical asymptote. Again, the period is pi units. Every pi units, you get a repeat. The domain, of course, is all x's, as long as x is not a whole number multiple of pi. I'm sorry, I should say an integer multiple of pi. Range, of course, from negative infinity to positive infinity. And the vertical asymptotes occur at every integer multiples of pi. Cosecant and secant, again, because we are not allowed to divide by 0, they're also going to have asymptotes. Right? Cosecant, of course, is the reciprocal of sine, and so anytime the sine of an angle will be 0, the reciprocal is going to have to be undefined. Notice on this graph that sine of x is in the lighter gray, and then of course you've got cosecant. Of course, the reciprocal of 1 is 1, so anytime sine reaches its maximum value of 1, cosecant will also have a value of 1. Or because the reciprocal of negative 1 is negative 1, anytime sine hits its minimum value of negative 1, cosine will also be at negative 1. But notice that the maximum values for sine of x coincide with minimum values for cosecant of x, and then vice versa. Anytime sine of x hits a minimum value, cosecant of x hits a maximum value. Now, even though there's an asymptote every pi units, the function does not repeat every pi units. It actually takes 2 pi for a complete cycle. The domain, again, it's all x's as long as x is not an integer multiple of pi. The range, hey, it doesn't just go from negative infinity to positive infinity, because you cannot be between -1 and +1. So the range is a union from negative infinity to -1 inclusive, from 1 inclusive to infinity. And the vertical asymptotes every integer units of pi. Secant. Again, if I'm going to graph secant, my visual aid is actually to graph cosine first, because anytime cosine hits a relative maximum or relative minimum, secant will do the opposite, either reaching its relative minimum or relative maximum. Notice that the asymptotes go over and through every pi over 2 multiple. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. The period again is 2 pi. Right? Even though there's an asymptote every pi units, the function does not repeat until you've traveled a total distance of 2 pi. Domain, again, it can be any x as long as it is not pi over 2 or pi over 2 added to an integer value of pi. Again, the range is a union of 2 sets. In the vertical asymptotes, pi over 2 units added to any integer value of multiple pi. For the IXL, I'm just going to actually have you practice more with the sine wave and the cosine wave. Those are the easier functions to quite understand what's going on with the amplitude, the period, phase shifts, vertical shifts. A little trickier graphing your cotangent, tangent, etc. And I think that the sine wave and the cosine wave have many more practical applications than some of the other trig functions.